Hi guys, so this is our first video for the online learning. I'm gonna just do a quick overview of how it's gonna start. It'll always start with this first page, just like it would with class, but I changed it up a little bit. So the agenda, that's just like the title of the day we're at. So this is the first day, this will be lesson 1. It revolves around a review, so something we've already learned. What exactly that review is on is gonna be, oh look, I have a typo, what's new? I'm going to be over here under the objective. So this goes back to multiplying, dividing, adding, and subtracting rational expressions. That's 4.3 and 4.4 if you're looking at your notes. And then just like the two parts on Schoology that you'll see, there's the understand and the practice. So the understand is this video that I made. It goes right off of your notes, which you'll see. And then the practice you'll find on Pearson, okay, if you're interested. So let's go here to Schoology. This is period 7, but it'll be with any period. So if you go to your notes, or if you don't have your notes, and go under chapter 4 notes, and then I'm going to start with 4.3. And all I'm going to do here is just walk through this example that we've already done, because you might already be good with it, you might not be, but it's been a while, so let's talk about it. I'm going to go to example 3 here. So, quick review. Remember how to multiply rational expressions. We have to get it in the simplified form, so we need to factor as much as we can. Factor whatever I possibly can. Remember the 4 ways of factoring. Let me see here. How to factor. Remember, we factor normally. We can do difference of squares. We can take out a common term, and we can factor by grouping. Okay, so that should be on that first page of the packet if you can find your 4.3 packet. But just to review, remember these are the 4 ways that we know how to factor. So I look at all my numerators and all my denominators. 5x can't be factored at all. X plus 3 can't be factored at all. I look at x squared plus x minus 6, right? This is a regular quadratic. I can factor it using the chart. So I need 2 numbers that multiply to -6 and add to 1. I get +3 and -2. Same thing with this denominator. I can factor it, right? That's a regular quadratic when my a is 1. 2 numbers that multiply to 1 and add to 2. +1 and another +1. This said x squared plus x. What can I do here? I can't factor it with the chart, right? I'm missing the c term, but I can take out a common term, right? X squared and x both have an x in common. So x out of x squared, I'll be left with an x. X out of x, I'll be left with 1. Okay, we tend to forget that 1, but remember, like 5 divided by 5, that's 1. X divided by x will also be 1. This denominator, I'll take out a common term again. 5 and 10 both have a 5 in common, so I could take out that 5. Once I take out my common terms, factor, whatever, then I look at this whole entire thing, and remember I have to do my domain. Do you remember where I look for my domain? I look for my domain in all of my denominators, okay? All of these denominators, that's where I look for my domain, even the ones that I canceled out, okay? So I haven't done any canceling in my explanation just yet, but it's the zero product property. So this is x plus 3. What value of x would make this 0? -3, right? So I have to say it can't be -3, because -3 plus 3, that would be 0 in my denominator. That can't be. I hope you can't hear my dogs right now in the background. This would give me a -1, -1. 5 isn't going to give me anything, so I can ignore it, and this would give me a 2. That's why my domain is this, all real numbers except -3, -1, and +2. And then I could cancel whatever I can. So I see there's an x minus 2 here, x minus 2, those are canceled. X plus 1 and x plus 1, those are canceled. X plus 3 and x plus 3, bye. And my 5s, 5 divided by 5, that's 1, so I can cancel them. And then I go across what is left, right? X and x give me an x squared, x plus 1. Here's your review of multiplication. Okay, there's my final answer and my domain, which we should talk about. Okay, make sure you have. Let's talk about division. So I'm going to go back to the chapter 4 notes. Let's look at 4, 3, 9, and 10. And we're going to look at Well, we know division is the same thing as multiplication. What's the only difference that we do with division? We have to multiply by the reciprocal, right? So if you just look at this first one, I kept the first fraction, the first rational expression, the same, right? Nothing changed. I changed the division to a multiplication, and I flip, or I make this the reciprocal rational expression. So it's now going to be x plus 5 over x minus 6. And then I'll continue, right? Take out a common term, cancel, find my domain, okay? That's division. I don't need to go further because it turns into multiplication. A quick review about adding and subtracting. We'll go to 4, 4, 11, and 10. So I'm using these notes because you already have these notes, and if you don't, I'm showing you where you can find them on Schoology so you can use them. Let's look at example 3. So when I need common denominators, right? In order to add fractions, add rational expressions, we need a common denominator. So here we can go step by step. So I don't have common denominator, right? I want to factor my denominators just like we would before using any of these 4 options, okay? And I can look at this denominator. So x squared minus 1, I see an x squared and a minus sign, and then just one more number. So kind of leads me into the direction of difference of squares, right? So 1 is a perfect square. We tend to forget about it, right? 1 times 1 gives me 1. So this red writing, that's the factored form of x squared minus 1 plus, because I'm finding the sum, factor this, 2 numbers that multiply to 2 and add to negative 3, negative 2, and negative 1. Once I factor my denominator, then I need to get a common denominator. I need to find my least common multiple of all of my denominators. Remember that phrase we used, one of each factor in my denominator. So this one has an x plus 1 and an x minus 1. This one has an x minus 2 and the x minus 1. I pulled one of each of them. I didn't repeat the x minus 1s. And then I look at the overall picture. What does this red writing have? Or what does it not have, right? It has the x plus 1, it has the x minus 1, it needs the x minus 2. Okay, so that's why I multiplied the top and the bottom, the numerator and the denominator, by x minus 2. Same thing over here, right? It had the x minus 2, it had the x minus 1. I need to multiply it by the factor that it's missing, the x plus 1 on the top and the bottom. Once I do that, I can really just write this as one fraction, or, I just added that x minus 2, multiplied that x minus 2 in there and the x plus 1 in there. Then I just have to simplify my numerator, just my numerator. X minus 2 times x plus 3 needs me to FOIL it, right? So I do first, outer, inner, last, and that's how I get this. And then I simplify, combine the x's to get this top part. The 2 I distribute. That's easy. 2x plus 2. Now I can write this as one fraction right here. Common denominator stays the same. And then I add my numerators, right? X squared, it's my only x squared. X plus 2x gives me 3x. And negative 6 plus 2 gives me negative 4. I can factor my numerator one more time. 2 numbers that multiply to negative 4 and add to 3 gives me this. And I want to do that because now I can cancel out my common terms. Okay, so x minus 1 in the top, the numerator and the denominator cancels, and I'm left with this rational expression. Okay, anybody remember the only difference between adding and subtracting? Only difference between adding and subtracting is I have to write down here, remember to distribute that subtraction sign. When I go to simplify my numerator, we need to remember that I'm subtracting each of these terms. Okay, so right here, after I FOIL, I want to keep that second part of my numerator in parentheses so I remember to distribute the subtraction sign. Okay, guys? So that's your quick review on how to multiply, divide, add, and subtract rational expressions. Feel free to use your notes. Email me if you have questions, but you're going to go ahead and try the practice on Pearson. Okay? Great job, guys.